Imagine an artificial intelligence
Right.
that could grasp the very essence of how everything works. Not just, recognizing faces or recommending movies, but truly understanding the dynamic interplay of our moods, global economic currents, or even the subtle health of an entire rainforest. Today, we're taking a deep dive into something really ambitious, the concept of a universal AI for pattern recognition, often referred to as the equilibrium engine. It's an idea that, frankly, challenges our very definition of AI. It suggests an algorithm capable of navigating and maybe even guiding the most complex systems on Earth, from the intricate wiring inside our brains to the delicate balance of planetary
Right.
ecosystems.
And it's a pretty significant conceptual leap we're talking about here.
Our deep dive today is based on this really fascinating report. It lays out not just the proposed technical architecture, the nuts and bolts, but also its profound societal implications, the ethical tightropes we'd have to walk, and its potential real-world applications. It's quite a lot. Our mission here at the Deep Dive is, as always, to give you a shortcut, to get you well informed about this cutting-edge idea. We want to provide those crucial insights, those aha moments you need, without you getting totally lost in the technical jargon. We want you to grasp the fundamental concepts, the exciting possibilities, so you can think critically about what this future might actually hold us holding. Okay, let's unpack this. What makes this equilibrium engine such a leap?
Well, what's truly revolutionary here, I think, isn't just an incremental improvement on the AI models we already have. It's more of a fundamental rethinking of how AI can interact with the world. At its core, the equilibrium engine is designed to understand and maintain a state of equilibrium. But, and this is crucial to get right from the start, this isn't a static, unmoving balance, like a perfectly still set of scales. Instead, the report really emphasizes it's about a dynamic, resilient condition, a state of optimal function and adaptability, where systems can thrive amidst constant change, not despite it or trying to prevent it. It's about being in flow, you could say, rather than being fixed. And that's a huge difference in perspective.
Okay, so let's start with a really foundational distinction the report makes. When you hear pattern recognition in AI, what comes to mind for you? Do you picture a system just scanning a database looking for exact duplicates of a picture you fed it, like matching a photo of your cat to, 100 other cat photos? Because the equilibrium engine is designed to operate on a much more profound definition than that. It isn't just a pattern matching system in that limited sense. That kind of system is, it's fundamentally constrained, right, by a pre-existing finite library of known patterns. It's like a librarian who can only find a book if you give them the exact title and author, and only if it's already in their inventory.
Exactly. It's limited by what it already knows explicitly.
This universal algorithm, by contrast, is envisioned as a true pattern recognition system. Its objective is to provide a reasonable probabilistic answer for all possible inputs. Even when the data is noisy, maybe incomplete, or completely novel, something it's never seen before, it's designed to perform the most likely matching by navigating uncertainty, by inferring deeper meaning. So instead of that librarian, think of it more like a detective arriving at a really complex crime scene. Even if some evidence is smudged or totally new or seems irrelevant at first, the detective interprets, predicts, identifies underlying structures. Take piece together the most probable explanation. It's an interpretive and predictive engine, constantly inferring, learning, not just comparing. And that shift, that's enormous.
Absolutely enormous. And the real breakthrough for achieving that kind of universality, as the report highlights, is that the algorithm's core, its methodological core, can't be monolithic. It can't be just one single giant model trying to do everything. Instead, it has to be a self-configuring meta-framework. It needs to exhibit what the report calls methodological plasticity, which basically means it doesn't just have different tools in its toolbox. It intelligently and dynamically selects, blends, and even chains together three primary paradigms of pattern recognition. And it does this based on the unique requirements of whatever problem it's tackling at that moment. So first up, we have statistical pattern recognition. You can think of this as the algorithm's foundation for dealing with uncertainty, which is inherent in almost all real-world data. It's a bit like a weather forecaster using historical data and probabilities to predict if it's going to rain tomorrow. It leverages probabilistic models, things like Bayesian classification, which is all about updating your beliefs, your probabilities as new evidence comes in, kind of like that detective ruling out suspects, or hidden Markov models, HMMs, which are really good at inferring hidden states from sequences of observations, like deciphering speech by understanding the subtle underlying sounds, the phonemes, even if there's background noise. These statistical methods are ideal for noisy, sequential data. Think understanding the subtle variations in human speech, analyzing complex bioinformatics data, or predicting changes in, say, financial time series data. Second paradigm, structural pattern recognition. This approach shifts the focus. It's less about individual data points and more about the relationships and the connectivity between features. Imagine trying to understand a family tree. It's not just about listing the individuals, right? It's about mapping out who is related to whom, the structure. This is critical in domains where the topology, how things connect and interact, is actually more informative than the individual data points themselves. Graph-based algorithms, for example, are great here. They can map complex social networks, revealing hidden communities or key influencers. Or they can help us understand the incredibly intricate folding of proteins, where the 3D structure dictates everything about its function. Or even the complex web of interdependencies within an ecosystem. In these cases, the connections, the structure, that's where the real meaning lies. And finally, the third piece of the puzzle, neural network-based approaches. These are the deep learning techniques that, in a way, mimic the hierarchical processing of the human brain. Think about how our own brains recognize a face or understand language. It's not one step, it's layers of processing. So convolutional neural networks, CNNs, they're paramount for processing spatial data, like images or video. They learn features starting from tiny pixels and building up to complex objects. While recurrent neural networks, RNNs, excel with sequential data, understanding the flow and context in a sentence, maybe, or a stock market trend over time, these neural nets allow the system to learn directly from raw, unstructured data. That's vital for things like medical images, satellite data, or processing complex audio inputs. What's crucial here is that these networks can automatically detect highly abstract and subtle patterns, often without needing humans to manually point out what features to look for.
Okay, here's where it gets, for me, really interesting. The true power isn't just having these three separate, powerful toolkits, right? The universal algorithm would be, as you said, a self-configuring meta framework. The report gives this brilliant example about imagine it's tasked with modeling the health of a rainforest. It wouldn't just pick one method and stick with it, no. It might first deploy a CNN, a neural network, to extract key visual features like canopy density and maybe color variation from high-res satellite images. That's the neural approach for visual data. Then it could switch to using a graph-based algorithm, the structural approach, to analyze the spatial relationships, the connectivity between different parts of the forest, mapping, say, nutrient flows or water networks to understand those interdependencies. And then it might employ a statistical model to predict the ecosystem's resilience to something like drought, based on historical climate data and current sensor readings. Dealing with uncertainty and sequential events, that's the statistical approach. The key insight, the real magic, is its ability to dynamically chain, integrate, and even optimize these diverse methods on the fly, tailoring its approach to each unique challenge. It's that flexibility, that intelligent orchestration that makes the universal claim plausible.
It's precisely that adaptive integration, yes.
So how does all this sophisticated recognition actually happen in practice? Day to day, if you like. The report describes this universal processing pipeline. It's a standardized yet adaptive four-stage workflow. Think of it like a meticulously designed factory floor, but for knowledge. First, you've got data ingestion and normalization. This is where the system pulls in and standardizes these vast, multimodal data sets from practically anywhere. Financial reports, genomic sequences, social media feeds, environmental sensor networks, medical records, you name it, it flows in. The critical step here is cleaning it all up, handling missing bits, making it consistent so that wildly different types of data can actually be compared and understood together. That's a huge task in itself.
It's a massive task, yes.
Yeah.
Often underestimated.
Then comes feature extraction. Here, the AI identifies the most salient attributes, the important characteristics within that normalized data, the bits that are really relevant to the problem at hand. You can think of it as distinguishing the signal from the noise, figuring out which pieces of information actually matter, and then representing that data in a form the computer can process most effectively. After that, we move to pattern detection and classification. This is where the core recognition magic happens, using that optimal hybrid model we talked about. It dynamically picks from those three core methodologies, statistical, structural, neural, to find regularities, anomalies, or maybe emergent structures in the data. And it can do this in a supervised way, learning from data we've already labeled, or totally unsupervised, discovering entirely new, unexpected patterns all on its own.
Which is often where the most exciting discoveries happen.
Exactly. And finally, the last stage. Insight generation and prediction. All those detected patterns and classifications get translated into something humans can actually understand and use. Clear forecasts, accurate classifications, actionable recommendations. This is the point where raw data, having gone through this intelligent pipeline, transforms into meaningful wisdom, knowledge we can act on.
And that pipeline, it's more than just a linear sequence. It's a dynamic system itself. If we look at the report's comparative analysis table, Table 1, it really highlights why this hybrid approach, managed by that intelligent pipeline, is so powerful. Each of those core paradigms, statistical, structural, neural network, they all have unique strengths, sure, but they also have inherent weaknesses when you use them alone. For instance, neural networks are amazing with unstructured data, but they can be these opaque black boxes, right? Hard to know why they decided something. Structural methods. Great for relationships, but they can be computationally really expensive. Statistical models handle uncertainty beautifully, but might struggle with highly abstract patterns that neural nets excel at. The core insight here is that by dynamically integrating them within this adaptable pipeline, the equilibrium engine effectively overcomes these individual limitations. This leads to significantly enhanced accuracy and maybe just as importantly, robustness across a whole spectrum of complex real-world tasks. Think about something like advanced handwriting recognition. It might combine a structural understanding of letter shapes with statistical models for handling variations in writing style and neural networks for processing the raw visual input from the page. Or consider the kind of intricate predictive capabilities needed for sophisticated financial modeling that absolutely requires blending all these elements. It's the synergy, the intelligent self-configuration within that pipeline that makes it truly robust and widely adaptable.
Okay, let's talk about this core concept, equilibrium. When we usually think of that word, our minds often jump to an image of something perfectly still, unchanging, like a tranquil pond maybe, or a perfectly balanced scale, a system totally at rest. But this AI's understanding, as the report describes it, seems far more profound, and frankly, a lot more aligned with how the world actually works. It really challenges that traditional idea of simple balance or homeostasis. The report basically says that the vast majority of systems this algorithm is designed to analyze, whether it's economies, ecosystems, biological organisms, human societies, they are not in a state of static balance at all. Instead, they are complex, nonlinear, dynamic systems, and they are perpetually, naturally, and sometimes even healthily out of equilibrium.
That's a key insight. Out of equilibrium isn't necessarily bad.
Right. These systems are characterized by a constant flow of energy and information flowing through them. They have intricate feedback loops where cause and effect are all tangled up, and there's this continuous interaction of many autonomous components, like individuals in a market or species in an ecosystem. Think of a bustling city or a living forest. They're never truly still, are they? Trying to force a system like that into some kind of rigid, unchanging state wouldn't just be unnatural, it would actually be counterproductive. It would lead to fragility and inability to adapt to the inevitable bumps in the road. So a really key insight here is that the equilibrium engine's goal isn't to impose a rigid stasis. It's to identify and foster a state of dynamic stability and resilience. It's about maintaining balance while constantly adapting. Like a surfer riding a wave, maybe, rather than trying to stop the wave itself. That feels like a much more realistic and, well, healthier approach for these complex systems.
Precisely. And this dynamic understanding brings us directly to the guiding principle of the equilibrium engine, this idea equilibrium seeking. In the context of these complex systems, this means guiding a system towards a state of, let's say, optimal function, adaptability, and long-term viability. While acknowledging that this optimal state is itself always shifting, always dynamic, the ideal state for these kinds of systems, according to a lot of complexity science, is actually one of self-organized criticality. It's a fascinating concept. Imagine a sand pile where you keep dropping single grains of sand. It builds up. Occasionally a small avalanche happens, resets things a bit, but sometimes a massive one happens. A system in self-organized criticality is poised right at that edge of chaos. It occupies that critical threshold between complete random disorder like the sand pile collapsing everywhere and rigid, unchanging order, like a perfect crystal that can't adapt at all.
So it's balanced on a knife edge, in a way.
In a productive way, yes. Systems that naturally evolve to this critical state, often without any external tuning, exhibit some remarkable properties. They tend to be highly resilient to disturbances. They're incredibly capable of adapting to changing environments, and they often display these beautiful, scale-invariant fractal patterns. Think about the intricate branching patterns of trees, how they maximize light exposure, or the detailed, efficient structure of our own lungs, maximizing oxygen exchange. These are hallmarks of healthy, robust natural systems that have sort of found their edge of chaos. Therefore, the equilibrium engine's primary directive isn't really to prevent change. It's to identify patterns or pressures that are pushing a system away from this critical resilient state, pushing it either towards too much rigidity or towards overwhelming chaos. And then its job is to recommend targeted interventions that gently guide it back towards that edge. So it functions more like a sophisticated resilience engine, ensuring the system maintains its maximal capacity to adapt and thrive through continuous change. Less like a simple stabilizer, more like a guide. It's like a planetary health manager, maybe, always nudging things back towards a dynamic optimum.
Okay, so if the AI is looking for these dynamic optimal states, these edges of chaos, what does this mean for how it sees the world, especially when it comes to the bigger picture? Well, a defining characteristic of these complex systems is something called emergence. This is fascinating. Emergence is where novel system-level properties and patterns arise not from some central command, but just from the simple local interactions of individual components. Think about market sentiment in economics. It's not something any single investor creates, is it? But it arises from the collective actions and beliefs of millions. Or consider consciousness in neuroscience. We still don't fully understand it, but it seems to emerge from the interactions of billions of neurons. Or even what we call ecosystem health in ecology. These aren't intrinsic properties of individual stocks or neurons or organisms. They're properties of the system as a whole that only appear at a higher level.
The whole being greater than the sum of its parts, essentially.
Exactly. And crucially, these macro-level emergent behaviors often cannot be understood, let alone predicted, by just studying the components in isolation. You can't figure out the overall market sentiment just by looking at one company's stock performance, for instance. The universal algorithm's strength, the report argues, lies precisely here. Its ability to process these vast system-wide datasets and identify those subtle, often nonlinear correlations across multiple scales. It can connect the dots between microscopic interactions and macroscopic phenomena, providing a kind of holistic understanding that's completely inaccessible if you only look at individual parts in a reductionist way. It sees the forest and the trees, and crucially, how their interaction creates something entirely new, something emergent and often unpredictable.
Right, so if we take this conceptual framework now and place it into the current technological landscape and also the regulatory one, it becomes pretty clear that this universal algorithm would represent perhaps the apotheosis of a general-purpose AI model, GPI. It fits perfectly, for instance, with the EU AI Act's definition, which is roughly an AI model that displays significant generality and is capable of competently performing a wide range of distinct tasks, and so on. Its core design, this inherent flexibility allowing it to be adapted to a multitude of downstream purposes, finance, medicine, climate modeling, you name it, really makes it the ultimate expression of this GPAI paradigm. And naturally, its development would absolutely rely on training with massive, incredibly diverse datasets, probably using self-supervision techniques at a huge scale. Mirroring the most advanced generative models we see today, like large language models, but with a potentially far broader scope of input and application.
Okay, so given that immense general-purpose power, it's crystal clear that such an AI comes bundled with immense responsibility. And importantly, serious legal obligations. The report actually uses the EU AI Act as a kind of blueprint for the minimum requirements any entity developing such a powerful tool would likely face. First off, there's the need for meticulous technical documentation. The provider, the developer, would have to create and continuously maintain these exhaustive technical documents, detailing everything about the model. Its architecture, its training processes, the vast data sources it consumes, how it's evaluated, and importantly, its inherent limitations. And this documentation wouldn't just be for their internal use, it would have to be readily available to downstream providers who integrate the algorithm into their own products and, crucially, to regulatory authorities for oversight.
Transparency is key from the outset.
Absolutely. Which leads to the next point, transparency for downstream users. Clear, comprehensive information would be absolutely essential for any organization looking to integrate this algorithm. This empowers them, right? It helps them understand its capabilities, its outputs, its potential pitfalls, so they can fulfill their own compliance obligations responsibly. And critically, copyright compliance would need a really robust policy. This includes respecting things like reservation of rights or opt-out mechanisms expressed by creators whose work might end up in the massive, diverse training data this thing would need. You have to ensure fairness and respect for intellectual property in an age where AI seems to have an insatiable appetite for data. These aren't just, technical hurdles to jump over. They're really foundational pillars of responsible AI development.
Indeed. And the very nature, the unprecedented scope of a universal algorithm means it would almost certainly automatically be classified as a GPI model posing systemic risks. Now, that designation isn't trivial. It's reserved for models whose failure, or perhaps misuse, could have a significant cascading negative impact on the market, on public safety, on fundamental rights, and not just locally, but potentially globally. This designation immediately triggers a much higher tier of obligations and scrutiny under frameworks like the EU AI Act. For instance, the provider would be mandated to perform rigorous model evaluations to assess and mitigate potential systemic risk, not just nationally, but thinking globally. And they'd have to conduct state-of-the-art adversarial testing, what's often called red teaming, to proactively identify vulnerabilities and potential failure points before they manifest in the real world.
So trying to break it before it breaks itself, essentially.
Essentially, yes. Proactive defense. Furthermore, a robust system would need to be established for serious incident reporting. This requires meticulous monitoring, documentation, and reporting of any serious incidents arising from the model's use, reporting them to relevant authorities like the EU AI Office without undue delay. This ensures a quick response and, importantly, continuous learning from failures. And finally, there's state-of-the-art conformance. The model would need to be continuously evaluated against standardized protocols and tools that reflect the absolute cutting edge of AI safety, security, and performance. This isn't a one-off certification you get. It's an ongoing commitment to excellence and safety in a field that's evolving incredibly rapidly.
That's a serious amount of oversight for just one model. But I suppose if we connect this to the bigger picture, it becomes obvious why. The scale of systemic risk posed by an algorithm like this would clearly transcend national borders, even regional ones like the EU. I mean, imagine the potential for profound cascading effects if this kind of power were misused or simply failed unexpectedly. It could destabilize the global economy in ways we haven't even conceived of yet. It could compromise international security on an unprecedented level, or it could accelerate ecological collapse if its environmental recommendations turned out to be flawed. Given that potential impact, national regulatory bodies, even coordinated ones, simply wouldn't be sufficient, would they? The report compellingly argues that the sheer magnitude of this risk would mandate the creation of a global, treaty-based governance body, something analogous to the International Atomic Energy Agency, the IAEA, which oversees nuclear energy.
That's the parallel drawn, yes.
This body would need to oversee its development, its deployment, its use globally, making the creation of the universal algorithm as much a diplomatic and legal challenge, requiring global consensus, as it is a scientific one. It's huge. Right, okay. Let's shift gears now and turn to one of the most complex, nuanced, and frankly fascinating systems of all, ourselves, human beings. How could this equilibrium engine possibly begin to understand us as individuals? The report suggests its application here offers profound opportunities, but also some pretty unique and maybe unsettling challenges. The idea is that this AI would function as a highly advanced form of artificial behavior intelligence, or ABI. Now, this isn't just about recognizing a simple action, like identifying if a person is walking or running in a video clip. No, it's deeper than that.
Much deeper.
ABI would analyze this rich tapestry of multimodal data about you. Everything from your posture, subtle facial expressions you might not even be aware of, the nuances in your vocal tone, the emotional cues embedded in your language, and even the surrounding environmental context you find yourself in. Its goal: to try and infer your underlying intent, your emotional state, and maybe even your likely future actions. This involves combining sophisticated AI techniques with principles from behavioral science, establishing normal behavioral baselines for an individual, detecting meaningful anomalies or deviations from those baselines, and adapting its understanding in real time as new data flows in. It's really about decoding human intent and predicting responses, not just observing surface-level actions.
And the primary application envisioned for this ABI, as outlined in the report, would be in mental health. This is a domain where the algorithm could potentially analyze patterns indicative of psychological distress with a sensitivity far exceeding human observation. Take, for example, proactive depression detection. The system could function like an advanced version of some apps we're starting to see, like mood capture. Using your smartphone's front-facing camera, perhaps, it could passively and unobtrusively capture in the wild images during normal phone use, not storing them, but analyzing them on the fly. Through image analysis AI, it could learn to correlate specific, often very subtle facial expressions, things like gaze patterns, maybe slight eye movement changes, or even muscle rigidity around the mouth, and perhaps even environmental features like the dominant colors or lighting in your surroundings, correlating these with the potential onset of a depressive episode. The idea is it could identify early symptoms, sometimes before the individual is even consciously aware of them themselves, offering a critical window for early intervention or support.
Wow, detecting it before you even feel it.
Potentially, yes. Then there's crisis intervention. By continuously analyzing, say, your digital footprints, linguistic patterns in your emails or texts, changes in your social media activity level or content, the algorithm could perhaps detect early warning signs of acute mental health crises. Things like suicidal ideation or the rapid onset of a depressive or manic episode. Some studies mentioned suggest that such systems might identify these crises with high accuracy and maybe even several days lead time. That creates a critical window for timely, potentially life-saving intervention by alerting designated caregivers or medical professionals. And finally, for personalized therapeutic support, the algorithm could power these incredibly emotionally intelligent interfaces. Think advanced therapeutic chatbots or highly immersive VR experiences. These could provide immediate, empathetic support for individuals experiencing emotional dysregulation, offering personalized grounding exercises, maybe helping clarify inner conflicts, providing a safe space to practice new emotional regulation skills in a controlled way. The potential for ubiquitous, immediate mental health support is, well, it's immense.
It really is. But here's where it gets really thought-provoking and maybe a little unsettling too. The report highlights this critical, maybe unavoidable challenge with this kind of pervasive behavioral intelligence. Human behavior isn't static when it knows it's being watched. Can you elaborate on this concept they call the AI assessment effect and what it means for how this engine would interact with us?
Yeah, it's a fascinating dynamic and a well-documented one. Research consistently shows this phenomenon, the AI assessment effect. Essentially, individuals actually alter their behavior when they know they're being assessed by an AI system. People tend to strategically, or maybe even unconsciously, emphasize their analytical and rational characteristics while downplaying intuitive and emotional ones. This often stems from a common belief, which might often be accurate, that AI systems prioritize those analytical, rational traits when evaluating performance or status.
So we put on a performance for the AI.
In a way, yes. And this creates this complex, continuous feedback loop. The algorithm observes human patterns, but the very act of observation subtly alters those patterns. This means the equilibrium engine can't just model a static human subject. It has to constantly model a dynamic, co-evolving human algorithm system. It needs to continuously recalibrate its understanding, accounting for our very human adaptation to being watched and assessed by it. Now, over time, this could lead towards what the report calls a quantification of the self, where an individual's sense of identity becomes increasingly intertwined with the metrics the algorithm tracks. The question, am I in equilibrium, might shift from being answered through deep introspection to simply checking an app or a dashboard. This could fundamentally alter social interaction, personal identity, potentially leading to greater self-regulation, maybe better goal attainment in some areas, but also risking a loss of spontaneity, authenticity, and maybe the acceptance of those non-optimal yet fundamentally human emotional states. It really changes our relationship with ourselves and potentially with each other.
Okay, let's zoom out now from the individual to the collective. Let's explore this AI's economic potential across different scales. The report details how the equilibrium engine could offer pretty unprecedented insights and management capabilities here. So, at the personal finance level, the system could analyze your individual income, your spending habits, your savings patterns, all of it. It would then generate highly personalized budgets, offer real-time financial advice tailored specifically to your goals, and maybe suggest optimal debt repayment strategies. We already see glimpses of this with existing AI-driven financial tools, right? Case studies show users can achieve significantly higher monthly savings rates. They're more likely to reach their financial goals compared to just using traditional methods. The equilibrium engine would just take this to a much more holistic, predictive level.
Integrating everything, yeah.
Then, at the market level, this algorithm could integrate and analyze this massive array of data streams, far beyond what any human team could handle. We're talking traditional macroeconomic indicators, GDP growth, inflation, interest rates alongside real-time market data, news articles pouring in from across the globe, and even potentially social media sentiment scraped from billions of users. By identifying subtle predictive patterns within this vast dynamic data set, the system could potentially produce highly accurate forecasts of market trends, price movements, volatility. Some existing simpler models are already achieving pretty impressive accuracy rates, like predicting major indices like the S&P 500 with, say, 76% accuracy or higher in some tests. The engine would aim to refine this dramatically, and then at the highest level, the global scale, it could potentially model the entire global economy as a single complex interlinked system. This would allow for the proactive identification of systemic risks, things like emerging asset bubbles, critical supply chain fragilities, potential inflationary pressures. And crucially, it could enable policymakers to simulate the impact of various interventions before they actually implement them, trying to prevent financial crises, promote sustainable growth, maybe even significantly boost global GDP. That's the promise, anyway.
A very big promise. And in the political sphere, the universal algorithm could, theoretically, serve as a powerful tool for enhancing democratic processes and improving the efficacy of government. For evidence-based policymaking, for example, by analyzing complex socioeconomic situations, identifying the most critical influencing factors, running in-depth simulations of potential policy outcomes. The algorithm could provide political leaders with a much clearer understanding of the likely consequences of their decisions. This could significantly reduce uncertainty in policymaking, allowing for perhaps more targeted and effective governance.
Less guesswork, more data.
Potentially. Then for enhanced public services, the generative AI capabilities, like those in advanced chatbots, could be used to create personalized and streamlined access to public information and government services. Imagine citizens being able to interact with AI consultants that can handle inquiries, manage complaints, maybe even process applications, all in their native language, preferred format, 24/7. This could make government more efficient, more responsive, and maybe, paradoxically, feel more human-centric by removing some of that bureaucratic friction we all experience. And thinking about AI-augmented deliberation, the algorithm could potentially facilitate more inclusive and effective democratic dialogue. By acting as a kind of neutral guide in deliberative processes, summarizing arguments, highlighting areas of consensus or disagreement, maybe ensuring all voices are heard, it could help bridge gaps between diverse groups, helping find common ground and compromise, and in doing so, perhaps strengthening democratic institutions and fostering more cohesive societies.
Okay, it's clear that this level of pattern recognition and predictive power could bring immense benefits to how we organize ourselves societally. But this raises a really important, maybe uncomfortable question. What happens if these powerful tools, designed for societal optimization, are repurposed or misused? Because the same pattern recognition capabilities that enable, say, beneficial governance could also be redirected for forms of social control and manipulation, couldn't they?
Indeed. And the report is quite clear in presenting this dual potential, this inherent tension. It really highlights the critical societal choices we face. For example, the algorithm could absolutely form the technical backbone of a sophisticated social credit system. By collecting and analyzing vast amounts of data on an individual's social behavior, financial history, legal compliance, online activities, it could be used to assign a trustworthiness score or a social credit score. Now, such systems, which are already being developed and deployed in various forms around the world, can lead to highly discriminatory outcomes. They can create blacklists that exclude individuals from essential services, things like Social Security, access to loans, even public transport, thereby restricting human rights and freedoms based purely on an algorithmic assessment of their good standing.
That's a chilling thought.
It is. And simultaneously, the generative capabilities of a universal AI pose a severe threat to our information ecosystem, potentially fueling misinformation and disinformation on an unprecedented scale. It could be used to create and amplify hyper-realistic misinformation, fake news, deepfakes, manipulated narratives, tailoring them to specific individuals or groups to maximize their impact and believability. The potential here is for deeply polarizing societies, completely eroding trust in institutions, and fundamentally undermining the very foundations of democratic discourse and collective decision-making. How do you have a democracy if you can't agree on basic facts?
Exactly. So this duality reveals this fundamental tension, doesn't it? Efficiency versus liberty. The very patterns that allow for potentially optimized governance and societal harmony are the exact same patterns that enable potentially totalizing surveillance and control. So the deployment and regulation of such an algorithm isn't just a neutral technical choice, is it? It's deeply ideological. A society's definition of what constitutes a desirable equilibrium, is it one that prioritizes collective stability and control above all else? Or one that prioritizes individual liberty and pluralism, even if it's messier? That choice will determine how the algorithm is constrained and utilized. The algorithm, in this domain, really acts as a mirror, reflecting and amplifying the core political values of whoever deploys it. Its use here is inherently, inescapably, a political act. Okay, let's pivot again. Let's explore how this AI could truly transform our understanding of human biology and health. impacting everything from how we diagnose individuals to how we manage global health systems. The equilibrium engine's potential in healthcare is described in the report as genuinely transformative, primarily because of its ability to recognize these incredibly complex patterns in biological data patterns that are often far beyond the limits of human perception. This leads to what the report terms superhuman diagnostic accuracy. It's a bold claim.
It is, but the potential is there.
Think about medical imaging, for instance. The system could analyze radiological images, mammograms, CT scans, X-rays to identify abnormalities like minute tumors, subtle lesions, hairline fractures, often potentially exceeding human radiologist accuracy while simultaneously reducing both false positives and false negatives. That's the goal. In pathology, it could rapidly scan digitized biopsies, looking for cancer cells, potentially cutting diagnosis time from days down to mere hours, and improving consistency across different labs. And in fields like genomics and proteomics, the algorithm could sift through these absolutely vast biological data sets. We're talking trillions of data points to identify specific genes, proteins, or other biological molecules that are the primary drivers of disease. This could drastically accelerate the process of drug discovery and development. This capacity for pattern detection at that microscopic molecular level really opens up entirely new frontiers for medicine, pushing us beyond what the human eye and mind can currently process alone.
Absolutely.
Yeah.
And this unprecedented diagnostic capability could enable a fundamental paradigm shift in healthcare. Moving away from our current model, which is largely reactive treatment of established disease, towards one of proactive, predictive, and intensely personalized health management. Take early disease detection. By identifying novel biomarkers, maybe recognizing previously unknown patterns in biological data streams, the algorithm could potentially detect the early onset of complex diseases, think various cancers, cardiovascular events, long before any clinical symptoms become apparent. For example, the report highlights AI models that can analyze the space around coronary arteries and CT scans, looking for subtle signs of inflammation or scarring. Now, these seemingly minor details turn out to be highly predictive of a future heart attack, even if the arteries themselves look perfectly healthy right now and pose no immediate threat. This allows for intervention potentially years in advance.
That's incredible. Intervening before the problem even looks like a problem.
Precisely. And then for personalized treatment plans, the algorithm could create this holistic, high-dimensional model of an individual patient, integrating their entire medical record, genomic data, proteomics, lifestyle factors, environmental exposures, maybe real-time biomarkers from wearables, all of it. Using this incredibly detailed model, it could predict with remarkable accuracy how that specific individual is likely to respond to different therapies. This is particularly powerful in areas like precision oncology, where the algorithm can guide treatment decisions by matching a tumor-specific genetic subtype with the most effective targeted therapy, moving us beyond those one-size-fits-all treatments into truly individualized medicine.
And it goes beyond just individual patient care too, right? Impacting entire healthcare ecosystems. The report highlights how this algorithm could optimize the functioning of whole healthcare systems. It could analyze public health and epidemiological data to track and predict the transmission of infectious diseases with much greater accuracy, allowing for more effective, timely control measures like targeted vaccination campaigns or resource allocation. It could also automate a huge range of administrative tasks, freeing up doctors and nurses. It could assist in complex surgical planning by simulating outcomes. It could even power the next generation of intelligent prosthetics and exoskeletons that adapt to a user's unique way of moving. So it's not just about better individual care. It's about improving the efficiency, the accessibility, and the overall effectiveness of the entire global healthcare ecosystem, making it more resilient.
But this pervasive application of the algorithm to our biology also fundamentally redefines the concept of health itself. It could shift it from being a somewhat binary state, you're either sick or you're well, to being seen as a continuous quantifiable spectrum of systemic biological equilibrium, measured constantly. This could give rise to a new paradigm, maybe something called biological citizenship, where individuals are increasingly expected, perhaps even pressured, to actively monitor and manage their data-driven health status, probably through continuous biometric tracking via wearables and sensors. Now, such a shift raises some profound questions for society. Questions about data ownership. Who owns this intensely personal biological data? What about the right to be unoptimized? The right to choose not to track or act on every single data point, to simply exist without constant algorithmic analysis. And it definitely raises the potential for new forms of discrimination based on one's algorithmic health score, or maybe even genetic predispositions identified by the AI before any disease manifests. These are not simple questions at all, and how we answer them will really define this new form of citizenship.
Okay, let's talk education. For centuries, education has largely been one-size-fits-all, hasn't it? Classrooms designed for the average student. Curriculum moving at a set pace. Imagine an AI that could just dismantle that old model entirely, tailoring learning precisely for you individually. That's a core capability described for this universal algorithm in the report. By continuously analyzing this rich stream of data for each student, tracking their real-time performance on tasks, understanding their preferred learning styles, their individual pace of comprehension, even their levels of engagement or frustration, the system could dynamically adjust educational content in real time.
Like a truly personal tutor.
Exactly, creating a unique, hyper-personalized learning pathway for every single individual. Like having a dedicated tutor whose only goal is to optimize your understanding and progress. We're talking about a significant evolution from the intelligent tutoring systems we see emerging now, like Dreambox for Math, which tailors lessons, or language learning apps like Duolingo, adapting exercise difficulty based on your responses. The universal algorithm would aim to integrate data from all aspects of a student's academic life, maybe even some behavioral cues, to create a truly holistic and adaptive educational journey. Something tailored precisely to your needs, ensuring you're always challenged but hopefully never overwhelmed.
And a key benefit of this kind of technological integration in education, the report suggests, is the potential automation of many burdensome administrative tasks that currently consume a huge chunk of educators' time. Think about the equilibrium engine handling grading assignments, maybe designing assessment questions tailored to individual student progress, personalizing lesson planning, even managing and automating routine parent communication. This could free up human teachers to focus on the higher value, uniquely human activities. In this new paradigm, the role of the teacher really evolves. Less of a dispenser of information, more of a facilitator of learning, a mentor who fosters critical thinking, creativity, and provides that essential socio-emotional support. It could empower teachers to be more human, connecting more deeply with students, rather than being constantly bogged down by paperwork.
And its impact isn't limited to traditional schooling either. It extends to addressing some really urgent societal needs in our rapidly changing world. We're seeing AI continue to automate routine and codified tasks across many industries, right? And the impact seems most acute right now in entry-level jobs, leading to this worrying decline in employment for young professionals in fields heavily exposed to AI. This creates an urgent societal need for continuous reskilling and upskilling, just to prevent widespread structural unemployment and economic instability down the line. The AI's potential solution here lies in personalized lifelong learning plans. By analyzing real-time labor market data, it could identify emerging skill gaps, maybe even forecast future industry needs globally. It could then recommend specific, targeted training modules and educational resources to help individuals acquire the skills they need to remain employable and thrive in this changing economy, maintaining a kind of dynamic equilibrium between workforce capabilities and market demands.
However, while this promises unprecedented efficiency in aligning skills with jobs, the integration of such an algorithm into both education and the labor market carries a significant risk. The risk is prioritizing economic utility above all else. Such a system could inadvertently stifle intellectual curiosity. It could devalue fields of study, think humanities, arts, pure sciences that might not have immediate, easily quantifiable market applications, but are absolutely crucial for fostering critical thinking, creativity, empathy, a deeper understanding of the human condition, and ultimately a well-rounded, functioning society. The fundamental challenge here lies in designing the system not just to optimize for economic productivity, but also to cultivate holistic human development. Ensuring a future where human potential isn't narrowly defined purely by market demands, that's a tricky balance to strike.
Finally, let's look at the biggest, most complex system of all, our planet. The report suggests this AI could be absolutely critical for navigating the immense challenges of climate change and protecting our natural world. The equilibrium engine would be uniquely capable, potentially, of processing and analyzing the immense, incredibly complex datasets that characterize environmental science. We're talking vast amounts of satellite imagery, real-time IoT sensor data streaming in from every corner of the globe, outputs from traditional physics-based climate models, pulling it all together.
The scale of data is mind-boggling.
It really is. And by seamlessly integrating its deep learning techniques with these existing physics-based simulations, it could potentially significantly enhance predictive accuracy for environmental phenomena. This could allow for far more reliable and timely forecasts of critical climate variables, things like global temperature changes, sea level rise, but also the precise prediction of extreme weather events like hurricanes, heat waves, wildfires, enabling vastly more effective early warning systems and disaster preparedness. This level of precision and foresight could be an absolute game changer for planetary health, allowing us to anticipate and maybe mitigate crises much better than we can now.
Absolutely. And this makes it an incredibly powerful tool for monitoring the health of the world's ecosystems and protecting biodiversity as well. For automated monitoring, think about using its AI-powered image recognition capabilities, analyzing satellite or drone imagery to automatically detect and track deforestation in real time, assessing forest health using metrics like NDDI, the Normalized Difference Vegetation Index, which shows how vigorous plants are, monitoring glacier melt, mapping land surface temperatures with unprecedented detail across the globe. Then in biodiversity tracking, it could be used for automated species detection, helping conservationists monitor wildlife populations, track migration patterns across continents, maybe even combat poaching through early detection of suspicious activity. We already see projects like WildMe using AI to identify individual animals through unique pattern recognition, aiding conservation efforts. The Equilibrium engine could potentially scale this globally, and crucially, it could help unlock citizen science. By mining the vast, often underutilized datasets generated by platforms like iNaturalist, where millions of people upload observations. These platforms hold this incredible wealth of secondary data on species interactions, animal behavior, habitat co-occurrence, things we often miss. The algorithm could potentially unlock this hidden treasure trove of information, enabling scientific discoveries that are currently just impossible due to the prohibitive cost and time of manual analysis. It could also power integrated modeling platforms like ARES, that's artificial intelligence for environment and sustainability, integrating all these disparate data sources to help stakeholders effectively manage ecosystems at every scale, from local watersheds to global biomes.
And beyond just monitoring, it could actively drive sustainability in very tangible ways across our industries. In agriculture, for instance, it enables highly precise farming techniques, optimizing irrigation down to the square meter, using exactly the right amount of fertilizer, applying targeted pest control only where needed, thereby reducing environmental impact, conserving precious resources like water, and potentially boosting crop yields all at the same time. In the energy sector, it could dramatically improve the efficiency of renewable energy grids. By accurately forecasting energy production from intermittent sources like solar and wind, and then dynamically matching that supply with real-time consumer demand, smoothing out the peaks and troughs. And in water management, it could monitor water quality in real time across vast networks, predict the onset and severity of droughts, allowing for more proactive and efficient resource allocation. It's truly about optimizing our interaction with the planet's finite resources, making our footprint lighter.
And the application of the Equilibrium engine at this planetary scale could enable a paradigm shift, moving from relatively passive environmental monitoring to a more active planetary scale system stewardship. The report even uses this provocative concept of a global immune system. The AI could function by continuously detecting critical ecological imbalances, maybe the early signs of a specific nutrient depletion in a vast ocean region, or a subtle shift in a keystone species population that signals trouble ahead. And then it could recommend targeted, multivariable interventions designed to restore equilibrium before cascading failures occur. So instead of just reporting that, say, deforestation is increasing globally, it might identify the specific region where a targeted reforestation effort would have the maximum positive downstream impact, considering effects on regional rainfall, biodiversity recovery, global carbon sequestration all at once. This allows humanity, potentially, to interact with the planetary ecosystem not with blunt, broad instruments, but with something closer to surgical precision, actively seeking to maintain its complex, out-of-equilibrium stability, which is ultimately crucial for our own long-term survival within it.
Okay, even with all this incredible power, all this potential we've been discussing, there's this fundamental question we absolutely must grapple with. Can we truly trust what we don't understand? This gets right to the heart of the infamous black box problem in AI, and the report is very clear on this. A system as powerful and consequential as the universal algorithm cannot be an opaque oracle. Its reasoning must be made transparent, interpretable to its human operators, and crucially, to those affected by its decisions.
It's a non-negotiable requirement for trust.
Exactly. As AI models, especially these deep neural networks, grow exponentially in complexity, their internal decision-making processes become virtually impossible for humans to comprehend, even sometimes for the very engineers who design them. This opacity is a direct threat to trust, to control, to accountability. Without a clear understanding of why an AI made a particular decision, whether it's denying a loan, flagging a tumor on a scan, or recommending a global policy shift, it's impossible to verify if it was fair. It's impossible to debug its errors effectively, or to hold anyone responsible for its outcomes. That's why this whole field of explainable AI, or XAI, is so incredibly critical. It's dedicated to creating techniques that can render these complex models intelligible, describing their expected impact, characterizing their accuracy and fairness, translating their decisions into terms humans can actually understand.
And to be truly trustworthy, the universal algorithm would absolutely need an integrated XAI layer, one that utilizes a suite of complementary techniques to provide meaningful explanations from different angles. One key technique mentioned is LIME. That stands for Local Interpretable Model Agnostic Explanations. You can imagine it like shining a tiny flashlight on just one specific part of the AI's complex decision process for one specific case, seeing which specific inputs seem to matter most for that single decision. LIME explains an individual prediction by creating a simpler, interpretable model that approximates the complex model's behavior just locally around that specific input. It helps to answer that crucial question: why was this particular decision made for this specific instance?
Okay, so it explains case by case.
Locally, yes. Another crucial technique is SHA, which stands for Shapley Additive Explanations. Now, this draws from cooperative game theory, believe it or not. SHA assigns an importance value to each feature for a given prediction. Think of it like fairly dividing up the credit among a team of collaborators for a project's success. SHA rigorously determines how much each individual input feature contributed to the final outcome. This provides a more robust and theoretically sound measure of feature contribution, ensuring the explanations are consistent and, in a sense, fair in how they allocate influence. And specifically for deep learning models, there's deep lift, or deep learning important features. This is more about traceability. It works by comparing the activation of each neuron in the network to some kind of reference or baseline activation, and then propagating these contribution scores backward through the network. This creates a sort of traceable chain of influence, showing potentially how specific input features led, layer by layer, to the final output, like a digital breadcrumb trail through the network's reasoning. Together, methods like these offer multiple lenses, multiple ways to peer into the AI's reasoning, each providing a different kind of insight.
That's incredibly powerful, giving us multiple ways to try and peek inside that black box. But the report also acknowledges that XA isn't some kind of magic bullet, right? There are deep-seated challenges, fundamental limitations that we really need to understand. Can you elaborate on those?
Absolutely. It's definitely a nuanced area. First off, there's this inherent and pretty well-documented accuracy interpretability trade-off. There's often this tension between a model's complexity, which frequently correlates with its predictive performance, its accuracy, and how easily interpretable it is. Simplifying a model significantly to make it more explainable can, ironically perhaps, lead to a decrease in its actual accuracy. And that's a trade-off that might be completely unacceptable in high-stakes scenarios, like accurately diagnosing a life-threatening disease, where performance is absolutely critical.
You don't want a less accurate doctor just because they can explain their reasoning better.
Exactly. Second, we face the challenge of audience-dependent explanations. A single type of explanation is rarely sufficient for everyone involved. An explanation that's deeply meaningful to a data scientist, maybe a complex graph or a list of feature importance values, might be completely opaque and useless to a business leader or a doctor relying on the output or a member of the public affected by the AI's decision. Crafting explanations that are both accurate and appropriately tailored to such diverse audiences, avoiding jargon while still maintaining fidelity to the model's logic, that remains a significant challenge. And third, there's the risk of oversimplification and misleading rationalizations. These post-hoc explanation methods like LIME and S-shape, they essentially provide a rationalization of the model's output. They tell a story about why the AI might have decided what it did. But these stories, these simplified explanations, may not fully capture the intricate, nonlinear reasoning process of the complex model itself. There's a real risk that these explanations can be misleading or overly simplistic, creating a false sense of understanding, a false sense of security in the model's decision, making us think we grasp its logic when we really only have a simplified approximation.
Okay, so if we take all these limitations together, what does this all mean for our future with such an incredibly capable, potentially universal AI? The report seems to suggest that the black box problem of a truly universal algorithm might not be just a technical bug we can eventually fix with better XAI. It might actually be a more fundamental epistemological boundary. As the algorithm's complexity approaches a truly universal scale, its true interpretability for the human mind might paradoxically approach zero. We might simply not be able to fully grasp it. We might be able to build a system whose outputs are provably effective. Maybe it consistently predicts market crashes, identifies diseases years in advance, optimizes energy grids with unparalleled efficiency, but whose internal reasoning remains fundamentally irreducibly alien to human cognition. This could force a profound societal choice, a choice between capability and comprehensibility. It might require a new social contract with technology based less on understanding its precise internal mechanisms and more on trusting its consistently verified beneficial outcomes. It's a leap of faith, perhaps, but one grounded in demonstrated utility and rigorous testing. Okay, beyond just understanding how these systems work, we absolutely must confront the ethical minefield that comes with such immense power. The report states unequivocally, really, that the immense power of the universal algorithm necessitates an equally robust ethical framework. Without explicit, legally binding guardrails, such a system risks perpetuating, even amplifying, societal harms on a global scale. One of the most critical concerns discussed extensively is algorithmic bias. This is when an AI system produces systematically unfair, discriminatory, or inequitable outcomes. And crucially, the report emphasizes this bias isn't usually some kind of malevolent intent programmed into the algorithm itself. It's almost always a direct reflection of the biases present in the data it's trained on and the assumptions, often unconscious, of the humans who design and deploy it.
Garbage in, garbage out, amplified.
Pretty much. Bias can creep in at every single stage of the AI lifecycle. From the initial data collection, if the data isn't representative of the real-world population, that's selection bias right there. Or from human annotators during data labeling, who might inadvertently introduce their own cognitive biases. It can come from the design of the algorithm itself, if it inadvertently favors certain features over others, or even from how its results are interpreted and applied in the real world. And this bias isn't theoretical. It manifests in tangible, real-world harm. We've seen discriminatory outcomes in hiring processes, in credit scoring systems, in predictive policing algorithms, and notoriously in facial recognition technology, where systems often have much higher error rates for women and people of color due to skewed training data. The universal algorithm, given its potentially global scope, would risk entrenching these kinds of biases on a truly global scale if not meticulously managed and rigorously addressed from the very start.
And beyond bias, the algorithm's fundamental nature, its insatiable need for vast amounts of diverse data to learn and recognize those complex patterns, poses a fundamental threat to individual and collective privacy. This is the erosion of privacy. We're talking about risks like the unauthorized use of intensely personal data for training purposes, the opaque black box nature of its decision-making when that data is processed, making it hard to know how your data was used, and the increasing use of sensitive biometric information collected from countless sources, often without full awareness or consent. Now, this erosion of privacy isn't merely a personal inconvenience. The report argues it's a profound threat to democratic values. The highly detailed behavioral profiles created by such an AI could potentially be used to manipulate individual choices, commercial, political, personal, to potentially suppress dissent by flagging patterns deemed non-compliant or subversive, and ultimately to undermine personal autonomy and the very freedom to think and act without constant surveillance and algorithmic judgment.
Okay, so given these inherent serious risks bias, privacy erosion, a robust ethical framework, isn't just nice to have, is it? It's absolutely non-negotiable for something like the equilibrium engine. The report outlines some core principles, drawing heavily from emerging international standards and guidelines that must form the foundation for governing such a universal algorithm. Can you walk us through those key principles?
Certainly. First and foremost is the principle of human dignity and oversight. The ultimate responsibility and accountability for the algorithm's actions, its decisions, its impacts, must always rest with humans. The purpose of AI should be to augment human intelligence and capabilities, not to replace or supersede human judgment or control. Human oversight is paramount, always in the loop. Second, fairness and non-discrimination. This requires proactive, continuous measures to identify, measure, and mitigate bias throughout the AI lifecycle. This includes things like ensuring training data sets are as diverse and representative as possible, utilizing advanced bias detection tools and fairness metrics during development and deployment, and conducting regular independent audits of the system's performance across different demographic groups and contexts to check for disparate impacts. Third, as we just discussed at length, transparency and explainability are critical, not just for developers, but for regulators, for users, and for those affected by the AI's decisions, building trust and allowing for meaningful scrutiny. And fourth, safety, security, and privacy by design. This means that robust cybersecurity measures to prevent misuse or adversarial attacks and strong privacy-preserving principles and technologies must be embedded into the algorithm's core architecture from the very beginning of its design process. They can't just be bolted on as an afterthought. These principles need to be foundational, built in from day one.
This raises a really important point, though, doesn't it? The act of debiasing a universal algorithm or implementing fairness isn't some neutral technical task you can just hand off to engineers with a checklist. It's inherently a politically and socially charged act of value setting. To correct for bias, you first have to define what a fair outcome actually is in a given context. For instance, in loan applications, is fairness equal approval rates across all demographic groups, regardless of other factors? Or is it a purely risk-based assessment according to some model, even if that historically leads to demographic disparities? There's no single easy answer. The equilibrium engine's objective is to maintain equilibrium, but the very definition of a desirable societal equilibrium is itself a normative, often contested value judgment. Therefore, the governance of such a powerful algorithm simply cannot be left to technologists alone. It requires a broad, democratic, and likely quite contentious process of public deliberation, involving diverse voices from across society to define the values that the AI will ultimately be programmed to uphold and optimize for. This is a conversation we as a global society absolutely must have and probably keep having. Okay, so with all this incredible capability and these profound ethical and technical considerations firmly in mind, what could this universal AI actually look like in our daily lives? How might it manifest? The report envisions a suite of tangible tools built upon the Equilibrium Engine platform designed to address user needs and benefit humanity by helping manage equilibrium at both the personal and the systemic levels. First among them is something they call the Personal Equilibrium Assistant, or PEA. Think of this as a hyper-personalized, holistic life management tool, a true digital companion working just for your equilibrium.
Your personal equilibrium coach, perhaps.
Exactly. So for financial management, the PEA would integrate your banking data, your investment information, your spending patterns from all your accounts to provide real-time, personalized budgeting advice, automated saving strategies based on goals you set, maybe optimal debt repayment plans, constantly guiding you towards long-term financial security and stability. In work-life management, by continuously, passively monitoring your digital work patterns, looking at your calendars, email volume, project deadlines, maybe even keyboard activity, the PEA could potentially detect early signs of burnout. It could then proactively suggest interventions, like scheduling a break, blocking out personal time, maybe even suggesting delegation of certain tasks as possible. It could also potentially identify optimal career pathways based on your skills and interests, and recommend personalized upskilling modules to ensure your long-term professional relevance and satisfaction. And in health and well-being, the PEA would passively monitor this continuous stream of biological and behavioral data from your wearables, your phone sensors, providing early warnings for both physical and mental health issues. From detecting the subtle onset of a depressive episode, like we discussed, to potentially identifying novel biomarkers for physical diseases much earlier. And it would suggest personalized preventative actions to help you maintain your biological equilibrium. It's conceived as a truly integrated life manager.
And then, shifting to the macro scale, for policymakers, for global leaders, the report envisions the Systemic Risk and Resilience Dashboard, or SRD. This tool would offer incredible capabilities, potentially allowing for much more proactive, data-driven global governance. The Global Economic Monitor module, for instance, would aim to model the entire global economy in real time, integrating every available data point to identify emerging systemic risks, those asset bubbles, supply chain fragilities, inflationary pressures, ideally before they metastasize into full-blown crises. And crucially, it would allow leaders to run sophisticated simulations of various policy interventions before they deploy them, trying to understand their likely impact, their potential unintended consequences across the complex global system. Then there's a planetary health dashboard. This would provide a holistic, real-time assessment of Earth's complex ecosystems, tracking key metrics related to climate change, biodiversity loss, resource depletion, identifying critical tipping points, and importantly, recommending the most effective, high-leverage interventions to promote global sustainability and perhaps even reverse environmental degradation in some areas. And finally, a sociopolitical stability index. This module would analyze global data streams, news reports, economic indicators, social media sentiment, maybe even satellite imagery to try and identify the complex patterns that often precede social unrest, political instability, or humanitarian crises. The goal here would be to enable proactive diplomacy and the more targeted, timely deployment of aid to prevent conflict and suffering. shifting us away from purely reactive crisis management towards proactive prevention on a global scale.
It sounds incredibly powerful. The report also describes a third type of tool, the Collaborative Discovery Platform, or CDP. This sounds like something designed to accelerate scientific and social progress at an unprecedented rate. Imagine researchers from basically any field being able to pose complex questions to this platform, asking it to find correlations across wildly disparate domains that no single human or even human team could ever process or connect. For example, an epidemiologist could ask it to look for patterns connecting climate change data, agricultural yields in specific regions, and the emergence of new infectious diseases, trying to find hidden links. Or maybe a sociologist could use it to investigate the nuanced relationship between specific urban design patterns like green space availability or public transport access and community mental health outcomes across different cultures and socioeconomic groups. The CDP wouldn't just identify these correlations. The idea is it would use its integrated XAI layer to propose potential causal mechanisms and testable hypotheses for further human-led investigation. It's like having the world's most powerful, most interdisciplinary research assistant constantly generating new leads, new avenues for discovery.
But these powerful tools, while offering this immense potential for control and optimization, present us with a final critical paradox for humanity. One the report doesn't shy away from, the very instruments designed to give humanity more control over its future by managing these complex systems could simultaneously, inadvertently perhaps, reduce individual human agency. Widespread adoption and reliance on such tools could lead to a world that is so optimized, so managed, that deviation from the algorithm's correct or optimal path becomes increasingly difficult or maybe just socially unacceptable. This could create a form of soft paternalism, where our choices are subtly guided, nudged, perhaps even constrained by algorithmic recommendations telling us the best way to live, work, or even think, leading to a world that feels incredibly efficient, maybe even safer, but perhaps profoundly less free. The ultimate challenge, therefore, is not just to build these incredibly powerful tools, it's to design them and govern them in a way that explicitly preserves and enhances human agency, choice, and perhaps the fundamental right to be suboptimal. These tools must be presented perhaps as offering a menu of possible futures and their likely consequences, offering options, clarifying trade-offs, rather than prescribing predetermined paths, leaving the final value-laden decisions about which future we want, where they belong, with humanity. Hashtag outro.
Wow. We have covered an incredible amount of ground today, diving deep into this concept of the equilibrium engine. We've explored its really ambitious blueprint for a universal AI, capable of unprecedented pattern recognition, from its dynamic hybrid architecture to its sophisticated understanding of complex, out-of-equilibrium systems. We've also wrestled with the profound systemic risks it poses and the intricate challenges of the human-algorithm interface, acknowledging the absolute imperative yet the fundamental limitations of explainable AI. And we've discussed the non-negotiable ethical landscape confronting issues of bias and privacy that simply must govern such a powerful creation.
It's a lot to take in.
It really is. And finally, we envision the tangible tools it could potentially manifest, from that hyper-personalized personal equilibrium assistant guiding your daily life, to the systemic risk and resilience dashboards attempting to manage planetary health and global stability, and that collaborative discovery platform aiming to accelerate scientific breakthroughs. Our mission today was really to give you a comprehensive, yet hopefully digestible understanding of what might be one of the most significant concepts shaping AI's future, one that could truly reshape our world in fundamental ways. The equilibrium engine paints this picture of a future where our world is profoundly understood, maybe even managed, by an AI that constantly seeks this dynamic balance. But it absolutely leaves us with the question, the really big question: what kind of equilibrium do we as humans truly want to live in? And how much control, or indeed how much of our own messy, unpredictable agency are we willing to yield to achieve it? That's a conversation that extends far beyond the technical realm, isn't it?
Indeed it does. This isn't ultimately just a technical or scientific challenge. It is a fundamental societal and philosophical one. It touches on our deepest values about autonomy, fairness, progress, and what it even means to be human. The choices we make now, as we contemplate and start to shape this kind of future, will define what it means to live in an era of potentially universal artificial intelligence. So we really encourage you, our listeners, to continue asking those critical questions, exploring these concepts further, and considering your own role in shaping this potentially extraordinary but also challenging future.
This is DigitView.